I welcome you all for the video lecture on data structures and algorithms. The topic to be discussed is Tree ADT. Let's recall data structure. We have linear data structure, which is sequential, and non-linear data structure, array, stack, queue, linked list, are linear data structures. Graphs, trees are non-linear data structures. ADT, meaning abstract data type, which is a property showing the essential information to the user, hiding the unnecessary and unnecessary details. Topics for discussion are white tree terminologies, tree ADT fundamentals, white tree traversals in real world. Let's explore the tree in nature, tree in computer science. We have a root node, edges, child nodes, unique part in tree in computer science. Tree ADT inspired by real trees in nature, but drawn upside down in computer science. Root at the top instead of bottom. Why trees matter in our real world applications? Let's empathize. We need a structure to represent hierarchical data efficiently. Like we have folders in computer systems, as file systems are example, and employee details in database is as we consider an organization as an example where there are hierarchies to be maintained. And we have object model programming language, HTML consider. It has tags, which is in hierarchy till order. So to represent these data, we need a structure. We can use trees to maintain these data, to store these data efficiently in a tree data structure. Tree ADT. Let's define. Tree ADT is hierarchical data structure which define with a finite number of nodes connected by edges having exactly one root and no cycles. Collection of node data is called a node. There is a relationship between a parent and child. It is hierarchical in nature, and it is recursive, and it is two-dimensional. Let's define three terminologies. We have a root. It is called a key node, and we have left subtrees and right subtrees. We have hierarchies. The higher hierarchies represent the parents, the lower children, and the relationship between them is called parent-child relationship. And there is an edge connecting two nodes, and it forms a path. And we have levels from 0 to n, and the height of the tree is of order the level n. And we have leaf nodes, the end of the tree, which does not have any other child nodes to more represented. And here is a tree. So you do an activity. Can you map your family members to these roles? Who is the root? Identify parent-child relationships. Find the siblings. Siblings are the nodes in the same level. And count the leaf nodes. Types of trees. We have binary, ternary, and n-ary. Binary trees are trees in which each node has at most two children. Ternary trees are trees in which each node has at most three children. An n-ary tree, many children at every node, and the number of nodes for each node is not known in advance. Traversal. In-order traversal, pre-order traversal, and post-order traversals are the three types of traversals. Traversal meaning traveling from one node to another node. So, in an in-order traversal, we need to traverse the nodes from the left subtree and then the root and then the right subtree. In a pre-order traversal, we first need to represent the root node and then need to traverse to the left subtree and then the right subtree. In the post order, we need to traverse through the left and right subtrees and then we need to go to the root node. The applications of trees in real world are database systems, programming compilers, AI decision making, game AI, etc. And let's detail it. Database systems, B trees and B plus trees, power MySQL, PostgreSQL for lightning fast queries. In programming compilers, path trees convert your code into executable instructions. In AI decision making, decision trees help AI systems that make smart choices in chatbots and medical diagnosis and many other fields as well. In gaming applications also, the trees find its applications like Minimax trees power chess engines and many other game engines in AI. Let's summarize through a mind map. Tree abstract data type, ADT. Fundamentals in definition, terminologies are root, parent-child, relationships, siblings, leaf nodes. Types of trees are binary tree, ternary tree, and n-ary tree. Tree traversals are in-order traversal, pre-order traversal, and post-order traversal. And then at last we have the applications. Comment the answer below for this question. That comes to the end of today's session. We will meet in another video and thank you all.